Thank you. Visually, we actually just switch the x's and y's and regraph it, correct? Algebraically, we switch the x and y and then solve. It's so beautiful. The idea is the same. Switch the x and y. So now normally I put like a little dotted line to tell myself, holy shit, if my pen would work, tell myself I'm doing something weird. And I switch the x and y, and then I start solving for y, right? So I get x minus 3 equals 2y to the 7th, and then I would divide by 2. I have no room down here, sorry. And then what would I do last step on this? Right, so I subtracted 3, I divided by 2, and what's the last step?
Take the 7th root.
Take the 7th root. Those will die, so I get 7th root of x minus 3 over 2. That's the inverse. Does that help? Who asked that question? Was it Tyler? I can't remember. Tyler, did that help out? That's number 3. Your actual number 3 is like just a little bit worse. It's got just a little bit extra going on, but not that much. Yes, no? Okay. That's the most important thing is not how to do any specific problem, but how to attack any problem that is like that. Anything else, guys, from the quiz? Oh, let me do this. From the quiz or from, what do you call it, Jeff? Homework?
Can we do the problem where we had to use like grouping? Like we had to factor.
Oh, yeah. Okay. The one that was like find the domain, but there was a thing to factor on the bottom?
Yeah.
Okay. All right, let's do a factoring problem like that. Let's see. Let me clear this away. Clear. Okay. Oh, I see why I'm not going to move that script. So something like, yeah, this is kind of boring. That's all right. I got one that I know works instead of just sitting here. I'm trying to make one that works. All right. So everybody, number 4, you had a problem where it looks something like this, and it was find the domain of this. Yes, right? Nobody had this problem, but everybody had this problem. The more you understand what I just said, the more you understand math. I'm a little concerned too. How many people do I have? 2, 4, 6, 8, 10, 12. 12 people. Okay. Well, I'm happy you 12 are here. I'm finding the domain of this. Can somebody get me started? What is it about this function that might have an issue somewhere?
The x can equal 0.
X can be 0 all day long. No problem with that.
The denominator can be 0.
There we go. Denominator can't. So denominator cannot be 0. So 4x squared minus 5x minus 6 cannot be 0. Now listen, if you used quadratic formula, I did not take points off, but I crossed through that shit because that should be a last resort. Just factor the damn thing. So can somebody else help me? Somebody I haven't heard from yet. Can you tell me what the first step is in trying to factor this? Good morning, Angel. It's a human person I can see. Oh, there's another human person I can see. Okay. Can somebody tell me the first step, very first step to factoring this funky thing? I'm getting a chat. Oh, the box method. Now the box method is interesting, where you sort of put in the box, like what the stuff is, but how do you get the stuff that goes here and here? Actually, I've got this wrong, right? I never use the box method. Hold on. To me, any method you use basically has the same amount of work, to be honest, but it's just a, so how does the box method goes, don't the results go inside, right? Yeah, the results go inside, but then you got to figure out what this is and what this is. There's still a first step there, even with the box method. Isn't this what you mean by the box method? Something like this, right? Who said box method? Is this what you mean by that? Thomas?
I think he does, yeah.
There we go. So Tyler has basically got it. Yeah. So would everybody agree with me? Almost any method you use, the very first step is to multiply these two things. And I'm not going to go through the whole, I mean, what, all right. Oh, chat. I think no, you're fine, Thomas. I'm pretty sure I put up on our Canvas shell. I might not have put this. This might be not a bad idea. But the whole idea of a factoring problem like this. Yes. Now, real quick, let me just do this. What if I had 3x minus 1, 2x plus 5? Okay. If I multiply this out, I get 6x squared. I get plus 15x. I get minus 2x. And I get minus 5. Now, is that right, everybody? Isn't that, whoa, and I'm not done. I don't give a shit. I'm not done. I don't care. What is 6 times negative 5?
Negative 30?
And what is 15 times negative frickin' 2?
Negative 30?
Also frickin' negative 30. So it kind of makes sense because the parts of this in this, the parts of it, the 3 and the 2, the 1 and the 5, don't they multiply and add to become the middle term? So there's a connection between the middle pieces and the outer pieces. And that connection is they have to have the same product because they're coming from the same parts or coming from a mixture of the parts. I don't know. Okay, that's a really quick thing. When I teach this, I kind of start with a lot of, if I just picked any other numbers and did it again, the exact same thing would happen. Does anyone not believe me? So what same thing? Somebody give me 2 numbers.
Two 2x plus 7.
All right, I like it. And somebody else give me another one. And it could have a minus or a plus, it doesn't matter.
6x minus 14?
6x?
Yeah.
Minus 14? All right, I love you guys. You're all like, let's make this shit huge. All right, so then I get 12x squared minus 28x plus 42x. Oh, what is that, Jeff? 98? All right, now somebody help me out. Somebody help me out. What is 12 times negative 98? 1176. Is that right?
Yeah.
That's right. I'm sorry. Negative 1176. Yes, does everybody understand what's happening? The first number times the last number is negative 1176. What is negative 28 times 42?
Negative
Same.
1176.
Holy shit. Okay. That's going to happen no matter what. No matter what. So we think backwards then. We go, obviously, this times this is important. That's the number, right? So I get negative 24. And if I get factors of negative 24, because remember the two middle numbers have to multiply to be the same thing that the two outer numbers multiplied to be, correct? So if I multiply the first and the last numbers, that tells me what that special number is. Now, what factors of 24, negative 24, make negative 5 when you add them?
$19? Wait, what do you mean when
So
you?
what factors of negative 24 make negative 5 when you add them?
Negative 8 and 3.
Negative 8 and 3. So then I can rewrite this. I love you guys so much. I really want this to make all the freaking sense in the world. Do you remember this? Here, I really want this to make all the sense. It's all right here. I sound insane. So this step here, right? This step here. How many terms are there? 4. Yes. This step here, four terms. Yes. And then I could group to go backwards. So this whole thing is about going backwards. So if I rewrite this 4x squared and I put the minus 6 not equal to 0, and then I use these minus 8x plus 3x to rewrite this, have I really changed anything Isn't that the same thing? Like if somebody said, is 2 plus 3 the same as 5? You're like, yeah, right? Is negative 8 plus 3 the same thing as negative? Yeah, so I just wrote this thing twice, didn't I? I just wrote it again. Ooh. But now what can I do? I can group, right? Take a 4x out, x minus 2. Take a 3 out, x minus 2. What tells me I'm on the right track here?
The values inside the parentheses are the same.
Yes, if these are not the same, it's no. You've probably made a mistake or it's not factorable, right? More than likely you made a mistake, but it's possible it's not factorable. Somebody did this and just kept going, even though that wasn't the same. Because what's the next step? What is the next step on this? What would I do for the next step? What's the very next step?
You combine like 4x plus 3, and then you have x minus 2.
And why are you allowed to do that? What did you actually just do? Does anyone know what you actually just did? Why are you allowed to do that? Why are you allowed to do that? I got a lot going on here, by the way. Let me get rid of some of this stuff here. I got a chat. I don't know what it says. Somebody read it to me. Hold on while I erase. Anybody want to read? Nobody? Okay.
Tyler said grouping.
Grouping. Okay. True, but that doesn't tell me. That just tells me what process. Why are we allowed to do it? Why? All right. Watch. This is nothing on you guys. Do you understand? This is nothing bad about you or something. This is just so easy, and you just get so used to the process, and you might not understand why it works. Can somebody tell me how do you factor 4xy plus 3y? How do you factor 4xy plus 3y? Factor that. How do you do it?
Take
out a
out
y.
the y.
Take out the y, and if I wanted to, I could put it here, correct? I just got to take it out, correct? Isn't that, and see where the y is? Isn't that where this guy is? Don't they each have an x minus 2? Didn't we just take an x minus 2 out because they each have one? And there you go. If they were not the same, you could not do the next step. So the people that make a mistake, if this would have been a plus right here, you could not do the next step. But the people that do it don't understand why it works. Shortcuts are great. But if you don't understand why it works, you're screwed. Okay, enough. That was a huge side note about factoring. So now that problem on number 4, some of you it's part A, some of you it's part B, but one of them looks something like this. So the domain, you just have to factor the bottom to see what can't be in the domain. So here the answer would be x can't be 2 and x can't be negative 3/4 if you solve this equal to 0. So x cannot be those things. 11. Anything, is that all right? Any questions on that? Anything else? Any questions on homework, the quiz? If you haven't looked yet, your quiz is graded.
Can you do finding the limit with factoring, but on the bottom, it's like, so if the limit is approaching -4, then it's like x plus 4 on the bottom,
Oh, hold on. Let me clear all this.
or
Something
on the
like-
bottom, it's just like x.
Holy shit, Jeff. Let's try to write so other people can read. All right. Let me catch up to you. So on the bottom, you would have x minus 4, like that. And it's going, let's say it's going to 4.
Yes.
So on the top, you'd have something like, you could do it, Jeff. Look at you go. Look at you go. Holy shit. Okay. Something like that.
Yeah.
All right. What do you do? Now,
How you
and this is not in section 2.1 or 2.2 where you make a table, correct? This is later when we talk about limit properties and stuff.
Yeah, this is the 2-3 homework.
So what do you do here then?
You factor the
And real quick, everybody listen, this is huge. So do something different. Listen to me. What is the very, very first thing you do for any freaking limit question anytime? What's the very first thing you do for any limit question anytime? You can do it. Come on.
Do you see if the X value, you can plug it in and get an
Plug it in.
output?
Plug the X value in, right? Don't start doing conjugates. Real quick, little side note, I love doing a problem like this because I'm an ass. I'm a real jackass. Let's do it like this. There we go. We'll make it something that comes out nice over X plus 6. And people start doing conjugate shit, right? What's the only time I have more work to do in a limit is if it comes out in what kind of ratio? What's an indeterminate form?
Zero
What do I
over
get?
zero.
What?
Oh, 0 over 0.
0 over 1 over 0 is not indeterminate. That would be some kind of infinity. So just got to figure out what kind of infinity or if it does not exist. What do I get when I put a 1 into this one?
Four over 7.
Yeah, I get 2 plus 2, 4 over 7. Done. I'm done. Yes? And if you're doing the conjugate, you might waste like 5 minutes on this problem. So no matter what the limit question is, well, I mean, no matter what's happening, you try to plug the 4 in. And what happens when I try to plug a 4 in here? I'll get 16 minus 36 plus 20 is 0. And 4 minus 4 is 0. And that is your classic, I have no freaking idea, right? That's indeterminate. I cannot determine the answer the way it is. Now you can tell me, what do I do to start to try to determine the answer?
You have to factor the top.
Yes. And I'll bet you anything that's a part of it. So then x times x is x squared. 4 times 5 is 20. And if it's negative, the signs work out. Yes. And then that cancels. What is really nice with what's happening right now? What's the worst parts of this? Of course, is this and this, because they're both. That's what makes it 0 over 0, right? So I love to think of it like this. If you can get the limit to a point where you can kill the problem, then there's no problem. That kind of sounds silly, but does that make sense? So now I kill it. Bam. Now can I plug a 4 in?
Yes, you can.
Totally can, right? And again, the reason this works, what is the one input that I'm not allowed to do this?
4.
4 is the one input. And what is it about this that makes that not a problem?
It's a limit.
The limit, what does that mean?
Approaches
Anybody
but
else?
Never gonna
never
touch
reaches
it.
it.
Sorry? Yeah. Say it again.
Oh, I said that it approaches 4, but it never reaches 4.
Yeah. That's the one value this limit doesn't allow to be used. So that's why I can kill this thing dead. All right. Because I'm not using that one value. Okay. Maybe.
Yeah.
Maybe.
Can you do the same thing when the limit approaches 0, but there's only x on the bottom?
Oh yeah. So it'd be the same idea. So the bottom is x. So real quick, if this was on the top, what do you guys think? What form is that in? When you plug a 0 in, what do you get?
2 over 0.
2 over 0. Is that indeterminate?
No.
No, it is not. It is some kind of infinity. Or it could be does not exist. So what happens when I put stuff in that's less than 0? Isn't this negative? And the top is positive? So that would be negative infinity. What if I put stuff in above 0? Wouldn't they both be positive? So that would be positive. So it's doing this kind of thing, yes? It's doing Jeff, try again, buddy. It's doing the same kind of thing as this. Oh God, that's really gross. But anyway, it doesn't agree on which infinity. So this would just be a straight up does not exist. Did I have to do a lot of work? Because that is not indeterminate. Right? And again, it's so beautiful. If it's not indeterminate, then I should be able to determine the answer. I mean, that's so beautiful. All right. So what you're talking about is something more like, what if I just put one extra little thing in here? Like that. Jeff. Good Lord. Now what do you get when you plug a 0 in?
0 over 0.
Shit, right? But then this is easy. Because how do you factor the top?
I'd take an x out, and it'll be a x plus 2.
Die. And don't forget your limit. You got to model good behavior. You always write the limit until the step you put the value in. And of course, now what do I get?
2.
Okay. Is that all right, everybody? Was there a more specific question you had, Chloe? Is that all right?
No, that's good. I just needed to be told that it could be something over 0.
Oh, definitely. That just means it's some kind of infinity. Can you do one with a natural log? Oh shit, I didn't mean to do that. Hold on. I just meant to clear this stuff. Well, how about this? How about this? If you can read that. It's always a challenge. What happens when you try to plug a -6 in? Where is there an asymptote for this?
At the
Zero?
0.
Yeah, at y equals 0, right?
Mhm.
Okay. I'm sorry, x equals 0. Good job, Jeff. So at x equals 0, there's an asymptote. So x cannot be zero. The input, the inside can't be 0. But what is this limit? And I should say this. Is somebody saying that to me?
Negative infinity.
Thanks, Thomas. Sorry?
You were asking what the limit is.
Yeah,
right,
I'm
the
sorry.
moment
Yeah, I
you
just
see on the
didn't hear.
graph.
Say, all right, go ahead.
So if it's approaching from the right, it's negative infinity.
Negative infinity. Yeah, and so this is the same idea, right? It doesn't matter where the input becomes 0, it goes to negative infinity. And if I would have put a negative, it would have not made sense because it doesn't even exist below -6 then. Yes? Okay. This, I think, was a question in the homework, but you had to find the domain for this one, but we made it into a limit problem. Is that cool? Okay. Thank you, Tyler. So let me catch you up on a few things, and then I'll see if anybody else has any more questions. On the board, you'll see I sent out an email this morning. I don't know how to point my fingers when I do this. Quiz moved to Wednesday. The test is next Friday. Do you guys remember that? What's happening this Friday? Holidays, right? All the presidents were born just so we could have class with day off from class. It was really nice to them. I'm born, take the day off. And then I will give a practice test this Wednesday, so next class, and then next Wednesday I'll have the answer key, and I'll have the quiz graded, obviously, much quicker this time because I won't be out of town as far as I know this time. Okay. So any questions on the near future for us in this class? Okay. All right. Popped out with the sign reading no class. Oh, they went to spank them, and there was a little tattoo on their ass saying, "Yeah, take class off." All right. Little known fact about some of our presidents. All right. If there's no other questions, homework. Did you guys anybody watch the videos I put up? Did they make sense? I had the worksheet that you could look at, right? The continuity worksheet. Let's look at that real quick. Hold on. Okay, get in there. Where did I don't want the syllabus, Jeff. I want the modules. Here we go. Perfect. I think I put the worksheet. Yes, thank God. So here's the worksheet that I went over in this video. Yes? Does this look familiar to anybody? The blazing. Okay, here we go. This worksheet. All So this is something you can ask questions about if you, I don't know, is that where some of these questions came from? Maybe. So if you have any more questions about this worksheet, we went through it on the video. This is from last semester. No, so you're free to ask questions from this if you want. This is from section 2.5. There's one idea in section 2.5 we haven't talked about yet, and that is the intermediate value theorem. So I don't know if anybody's run into that yet. And you're all like, dude, I'm still finished up 2.3, or maybe 2.2, or maybe 2.1, or maybe chapter 1. If you haven't finished chapter 1 homework yet, you are behind for sure. Okay. So let's do this. Let's start off with a discussion about intermediate value theorem. Then I'm going to talk a little bit about both 2.7 and 2.8, and then we'll call it a day. And on this Wednesday, we'll have in class, we'll go over questions. I have a worksheet that I'm going to have you work on in breakout rooms. Yay, Zoom and breakout rooms. It's all great. Just keep remembering next week. We're actually together next week. Yay! I don't know how you feel. Some of you guys are looking forward to it. Okay, so intermediate value theorem. Let me ask you a question. See if anybody gets the idea behind this. Let's say I have, get in there. Okay, everybody got all this, hopefully. It's all gone away. Bye. Okay. Yeah, let's say I have this function here. Why are you so wobbly? I don't know. Oh, 4x cubed minus 6x squared plus 3x minus 2. And I'm curious, show there is a root of f of x in the interval 1 to 2. Oh man, we got the glare thing going on. Is it you? Is it you? What is it? Is it you up here? It is you up here, I think. Let me see what I can do. Is that better? A little bit better. Yeah, that's better. Okay. So everybody, does everybody understand what root means? Can somebody tell me what root means? What is the root of a function? What does that mean? The root of all evil. No. Anybody? What's the root another name for?
A 0?
And what does 0 mean? Well, he's like, what the hell do you want from me? It's x-intercepts. How do you, we use many words for x-intercept, well, many. Roots, zeros, right? So x-intercepts, we call them roots because the x-axis is like the ground, and that's where the root starts. We also call them zeros because that's where the function equals 0. So I want you to show me there is an x value between 1 and 2 that makes this function 0. Do you want to use guess and check? Like, do you want to just start plugging in there like 1.7? Well, that's not 0. 1.6. Well, that, because what couldn't the answer be 1.5924769334110? Are you going to get that trial and error? Do I even give a shit? Does my question say find the root? No, it just says show there is a root. Okay. Does anyone have any suggestions on what to try to do to show there is a root? Yes, and let's think, what does that mean visually? If there's a root, what does this function have to do between 1 and 2?
That's the x-axis.
Yeah, so whatever it's doing, it could be up here. I'm just gonna, I don't know if this is what it looks like, so it could be this, but somewhere between there, it's gotta go through, right? I like it. And I think I said this before, I can't remember what context. I drew it one way. Couldn't it have been from here up? But can somebody tell me, on this side, all the outputs are positive, correct? And on that side, all the outputs are negative, correct? And doesn't that make sense? Doesn't that make sense? Doesn't that make sense? The only way that a well-behaved function, this is a continuous function, right? It's a polynomial, so it's continuous on its domain, which is everything. Remember that? Remember that? You got to kind of take that to heart, put it in your head. You don't have to memorize what the theorem says, but stuff like trig functions, root functions, polynomials, rational functions, they're continuous on their domain. So this bad boy is the most well-behaved function. It's a polynomial. Those are beautiful. So it can't suddenly teleport itself, right? It's got to go through everything. So therefore, if it's positive on one side and negative on the other side, there must be a root in the middle. There must be a place it goes through the x-axis. Does that make sense? So how do I do that with what they've told me? You can do it. Come on. What is f of 1?
-1.
-1. What is f of 2?
$12.
Of course it's 12. Why would it be 12? So f of 2 is 12, is that right? Oh shit. All right, I'll take your word for it. So my scale sucks, that's too bad. So basically I have this situation. At 2 it's up here, and at 1 it's down there. Well, somewhere in the middle it's got to go through. That's the only way they can connect, right? Okay. How bad? Oh, I haven't written it down yet. So it's 12. I was thinking the glare is so bad I can't even see 12, but I didn't write it down. What? Real quick, watch. I really want you guys with me. Oh shit! Can somebody do 1.5 real quick? What do you get when you put a 1.5 in? Somebody can do that. I know you can. Just put a 1.5 in.
2.5.
Again, sorry.
2.5.
2.5.
Yeah.
Oh, that's nice. So look what this means. Look, isn't it negative at 1? And isn't it positive at 1.5? So isn't there a root somewhere between 1 and 1.5? Can you see how you can keep going? You can do 1.25 now. And then you can kind of zero in on where the root is. I like it. Okay. So somehow this connects to intermediate value theorem. I like to start here because this is kind of concrete and it makes sense. If a function's going along and it goes from positive to negative, it's got to go through 0 if it's continuous. So here's what intermediate value theorem says. Affectionately known as the IVT. If I'm given a function f, given f of x, that is continuous on some interval a to b. It doesn't have to be continuous everywhere, just on some interval. That's the word on. Okay, there we go. On a to b, let some n be between f of a and f of b. I'm going to give us a visual in a minute where f of a does not equal f of b. So I have, let me give us a visual while we're doing this. So I have some function that's continuous a to b. It's got an f of a and it's got an f of b. And n is between f of a and f of b. Of course you did, Jeff. Why wouldn't you? It doesn't really matter which one is where. Okay. So n is between f of a and f of b. Doesn't it make sense? Then obviously there's got to be at least one place. So here's the idea. There must be at least one input. There exists a C in A to B. There exists something between A and B where f of C equals n. Holy shit. That's confusing, but visually I'm hoping if I got f of A, I got f of B, and it connects. It's continuous, right? It's continuous. And n is anything in between. There must be an input that has that output. It can't skip it. It can't jump over it. That's intermediate value theorem. And I assigned one of my favorite problems. Somehow intermediate value theorem relates to a monk climbing a mountain. So have fun with that. I think it's the very last problem. And if you don't quite get it, it's fine. But I'm telling you, the easiest way to answer that is to draw a graph for the monk mountain problem, which is in your future. Okay, I mean, this is a little technical and confusing, but all it's saying is it's got to go through every value between, and that's what intermediate. It takes on every intermediate value between this output and that output. That's why it's called intermediate value theorem. Okay, enough of that. There's no questions on that? Does that make sense? Especially to the person that, oh, you were gonna, okay. Somebody was gonna ask about the monk problem. Well, if you tried it out, try it out again. I don't know if what I said is gonna help you. Oh, what am I doing? I wanna keep up here, I think. All right, so. Why didn't I write that down? Shoot. I was gonna do a couple of things from section 2.6. Yeah, that's right. I remember now. Before we get into 2.7 and 2.8, why are you on? What's that? See if I remember what they were. I think so. Let's see. Yeah, there's this one. All right, who thinks they know what this is? Anybody want to step up and take a guess? And being completely wrong is fine right now. Just no pressure.
Is it positive infinity?
Maybe. So I got one guesstimate is positive infinity. Does anybody else think? Does not exist is kind of correct, but we want to be more specific. So we'll tell you there's a specific, more specific than does not exist. So somebody else says positive infinity. Anybody else think it's something else besides some kind of infinity? Or you guys all, I mean, this is the only kind of answer you can't give me is the answer is carrots or something, right? Obviously it's a number, right? So other than that, you can just wildly guess. Does anybody think it might be 0? Y'all, okay, it's if not, good, because that's not the right answer. So some people might think it's 0 because they think it's infinity minus infinity. Isn't it infinity minus infinity? Yes, isn't that what it is? What's infinity squared? Infinity, isn't it? And so I get infinity minus infinity. So you can see how somebody might think it's 0. Does everybody agree? You can see how somebody would think it's 0. And it might be some of you and you just don't want to speak up. I understand. Now, why is it not 0 then? Why is it positive infinity? Well, the way I can look at this better is to factor it. What's this? As x goes to infinity, this goes to
Infinity.
Infinity, that's crazy. And what is this? As x goes to infinity, what's x minus 1 going to?
Infinity minus 1.
Well, which is infinity, correct? Infinity minus any finite amount is infinity. If I had an infinite number of ducks and I lost one, I still have an infinite number of ducks. It's crazy. So an infinity times infinity is freaking infinity. Yes. All right, so that's kind of interesting. You got to be careful about infinite limits, because let me ask you this. Which one of these is going to infinity faster? Which one's going to infinity faster? X squared or x? Sorry.
X squared is going to infinity faster.
X squared is going to infinity much faster, right? 5 is 5. 5 squared is 25. 10 is 10. 10 squared is 100, right? So if I look at a table, 1 minus 1 is 0. 100 minus 10 is 90, right? Oh, shit and a half. What is this? 10,000 minus 100 is 10,000 minus, you can do it, Jeff, 9,900. So this is obviously, the difference is getting larger and larger and larger. Okay, enough of that. There was something else that I just cannot remember what it was. What was it I wanted to say? That's too bad, Jeff. Okay, so 2.6 is the one I gave you the video for from last semester. So you have to watch the video, you got to try the problems out, let me know if there's any issues. We basically covered most of 2.6 talking about limits before. So 2.6 should be sort of a review for us from earlier stuff we did. Okay. Now we get into the meat. Now we are finally completely ready to do calculus. We haven't really done calculus yet, believe it or not. We really haven't. So I sort of did, because I sort of did this early. So here's the thing. All right. So section 2.7, what it tries to do is if I have a function and I want to know the slope at a point. So I want to know the slope of f of x at a. There are two ways to do it. So the first way, one way to do this, is to take some other point. I'm going to call it, it doesn't matter where it is. I'm going to call it x. And we find the secant line, yes? We find the secant line. Oh, Jeebus, Jeff. Let's not use red. Red's a little bit faint. Okay. Remember secant line? So what is the slope between these 2 points? At A, the output is f of a, and at x, the output is f of x. That's amazing. So what is the slope between what are the 2 points we have? This point is what?
What did the slope be? F of x minus f of a over.
Oh, you're getting ahead of me. So this point is a f of a, and this point is x f of x. So the slope would be, I think you started saying it, right? y2 minus y1 over x2 minus x1, right? Is that cool? Okay. Now, here's where this becomes calculus now, is this is the slope between those two. That's the secant line slope, right? How do I get the slope of f of x at a? What do I have to add in here? I want to get what the slope is at A. What do I have to let this point do? If I want it right at A, what do I do with this point? I want to let it do, I'm not going to move this one. That's the one at A. What am I going to do with this point?
Get closer to A.
Get closer to A. So the limit as X goes to A of this. Once I put the limit onto this, that is now calculus. That is the instantaneous rate of change of the function at A, which is impossible to get in algebra unless it's a straight line. So let's do a specific example. Would you like a specific example? Yeah, you guys are so needy. Okay, we'll do it. And I'm going to make it nice and gross. Here we go. So everybody got this written down? Okay. So let's give us a specific example. I'll leave this up here for now. Right down to there. Okay. Example. Let's say f of x is x cubed. Become a 3. And I want to know the slope of f of x at it doesn't matter, Jeff. There it is. Okay. Slope of f of x at 2, which has this notation. Let me tell you what the notation is. I'm almost certain you guys have seen this. So the question really is, f prime at 2 is what? So this is how you say this, f prime at A. And that really means the slope, right? So when I see this symbol, that's called prime, and this is called the derivative. So this is our first definition of the derivative of a function. So that little thing means the derivative of f at A. So derivative and slope, same things. So really, in a sense, derivative is a process by which we get the slope at a point. But derivative and slope, derivative and rate of change, they mean the same thing. Okay, I like it, I like it. So, what do? I do this. So I do the limit as x approaches 2, right? Because A is 2. Is everybody cool? A is 2. That's the point I'm interested in. The limit as x goes to 2 of f of x minus f of 2. What's f of 2?
8.
Yeah, so f of x is x cubed. F of 2 is 8 over x minus a. Now, does everybody agree that this is in indeterminate form? What form is this in when I put a 2 in?
It's 0 on numerator and denominator.
0 over 0. So what can we do to actually get this to work? How can I get this to a point where I can figure out what the limit is? We did this a bit ago. What is this screaming to be done? What is it like? Do this to me. What do I want to do to this so I can maybe plug a 2 in?
Factor it.
Factor it, because I'm hoping that the part that makes it 0 cancels. I want to kill the problem, right? This is not general life lesson. When you have a problem, kids, don't just kill it. Okay, don't this person, don't kill him. I'm not advocating for that. Okay. How do you factor? Don't say anything. Don't say anything. Factor the top, please. Don't say anything. So I'll help you out a little bit. There's a little dude and there's a big dude. So this is x times x times x. So I'm going to put 1x here, the other 2 there. This is 2 times 2 times 2. So I'm going to put 1, 2 here, and the other 2 2's there. Same sign in here. Opposite than that is here. And what goes in the middle here? What goes right here?
2.
No?
2x.
2x. It's always this times this. Can I kill the problem?
Yes,
kill-
with the x minus 2 on.
Yeah, the problem disappears. Look at that shit. And when I plug a 2 in now, I get 4 plus 4 plus 4, 12. Now, real quick, was that difficult? Well, if you don't like cubes, maybe a little bit. But think about this. In this form, could I make this really difficult? Yes, I can. This is a relatively nice function. Couldn't I have made the function x to the 7th plus 5x to the 6th minus 4x cubed plus 2x minus 7? Can you just think a little bit about what this would have looked like then? So we have got to develop better ways to do this, correct? I made this function nice, yes? Yes, I did. And it's not always going to be nice. Okay. Now, how's everybody feel about this? This is not that much work. It isn't. This could get gross, but we're going to develop some different things. We're going to be okay. But the basic idea is pretty straightforward. Now, I really want us, now watch this. I'm going to take this one. So here is a cubic. Let me make it a little bit nice. 2, 4, 6, 8, 10. Okay. -2, -4, -6, -9. So we can do this, Jeff. So there. No, Jeff, that's 2, buddy. You can do it, buddy. There it is. There. 2 goes to 8. -2 goes to -8. And then it's like, gee, oh, Jeebus. Oh, this is so good, Jeff. All right. And then what we just figured out is the tangent line at 2 has a slope of 12. So this would be the tangent line at 2. It's actually not bad for me, this picture. Now, can you help me figure out the equation of this line? We know the slope is 12. Do we know a point that this line goes through?
2, 8.
Yes, beautiful. We know it goes to the point 2, 8. Input, output. So it goes to the point 2, 8. Do you guys remember your algebra well enough to figure out the equation of a line with slope 12 going through 2, 8? Do you guys remember this equation here? If you want to do it this way. No, maybe yes, maybe no. So it'll be y minus the y piece equals m times x minus the x piece. So it'll be y equals 12x minus 24 plus 8. So I get 12x minus 16. Is that what you guys get? Okay, now. Okay, so now we're gonna do this, if I can. Let my chair in here. All right. You guys doing all right out there? I throw a lot of stuff at you, I know I do, but it's all cool. Yeah. All right, hold on. See, where's my calculator? Come on, calculator. There you are. All right, let me open this up. It'll take it a minute, everybody. Anybody watch the Super Bowl? I did not. I was on a plane. and I'm fine with it. I actually don't care that much about it, to be honest. It'll never get as crazy as the one I saw way back in the early 2000s. But you guys know what one I'm talking about. I saw it live. All right, Snoop and Eminem. That does sound crazy. All right, so here's what I want to do. Let's graph x cubed. You can do it, Jeff. There you go, my friend. Let's graph x cubed, and let's graph the tangent line. All right, I caught up to you. I'm an old guy. Whoever wrote FR, I thought it was French, but you mean for real. Okay, I'm with you now. What is it we got for the 12x minus 16? Is that right? I don't want to turn around for some reason. So this should look Mercy Buttercups. This should look a little bit like the graph I drew, just better. So let's see. Everybody with me so far? One of the best things to do for yourself is to hit Zoom 6 whenever you're doing a new graph. And there you go. Look at this. Oh my gosh. So what I want to do, let me show you this. If you hit Zoom, the very first option is Zoom Box. So let's do this. I like Zoom Box. What Zoom Box does is you can put the cursor anywhere and then you hit enter. And now that is the bottom corner of a box. This is sort of like enhance in CSI or whatever. So I can zoom in on that piece of the graph. Bam. And look how close this gets in here. It's perfect at 2, of course. If I start to trace this thing, let me see how, I don't think I can get a little close to 2. So at 2, it's perfect. So if I bounce between the two, they're really close. They're really close. But of course, the further I get away from that, the more different they are. Yes? Because a tangent line doesn't curve, but the actual function curves. So the further away I get from the point that I did the tangent line, they can diverge. Okay, this is sort of like why, does anybody know that flat earthers still exist? If you are a flat earther, keep it to yourself. But on one level, you can understand because the Earth is very much a sphere, but the fact that we are sitting on it, we are so close to it that it looks flat, right? If I zoom in on any curve, it will eventually look flat. Yes? Okay. All right. I like it. So please don't, please be careful, kids. We landed on the moon. The Earth is a globe. All that kind of stuff. Okay. All right. People paid flyer to prove it's fine. They proved the current. They did. This is very true. 15 degree per hour drift. Yes. Okay. I'll stop. Now, how do we feel about what we just did? Did it make sense? You just have to do some of it to get used to it. This equation about this question, find the equation of the tangent line, you're going to see that so much this semester. I'm going to ask that question so often. So just, get ready. Now, let's do this. We're going to do this whole thing. We're going to do it a different way. And this other way is the more preferred general way to do this. This is the very first kind of method. We're going to do it a way that should look very familiar. Let me see, where am I at? There we go. Get in there. Okay, I got time. Okay, I'm gonna keep this up here. So I'm not even, all right. We've already seen this, right? Yes? And this is the whole idea of I have a function doing some weird shit. I want to know what the slope is at some point, and what I do is I go a plus h, and then I let h go to 0. This is also f prime at a. So there's two main methods to figure out the slope of a function at some point. My internet is a little, am I coming through all right? I'm a little, all right, I'm a little choppy. Okay. So let's do it again using this method. So what does this look like? The limit as h goes to 0 of, now what is f of a plus h? What is f of a plus h? What is f of x? What do I do to anything that I put into f? What is f of 2? What is f of 2?
8.
8. How did you get that?
I cubed it.
Yeah, you cubed it. What is f of 3?
27.
Holy shit. What is f of w?
W cubed.
W. So what is f of a plus h?
A plus h cubed.
A plus h cubed. Okay. We got there, everybody. We got there. And then f of a. Oh, let me back up a second. How much do I want to write and rewrite? I don't know. What was a again? Let's be more specific. What's a? What is a?
2.
2. It's always the point you're interested in. It's always the input that you're interested in. And we're interested in the point 2 for this problem. The location of 2. So the limit as h goes to 0 of 2 plus h cubed, Jeff, minus f of 2 is still 8 over h. So when I do this, right, this looks exciting now, right? Oh boy, too bad. So when I do this, let me do this real quick. It'll be h cubed plus 6h squared plus 12h plus 8. Is that right, Jeff? Yeah. Okay. So you're going to trust me on that. Yeah, hopefully. Oh, and I forgot minus 8, right? So this, I foiled it out real quick, and I got this. Is everybody with you? If you guys don't trust me, you can do it. I'm going to show you in a minute how I did that in my head. I did this in my head. I'll show you in a minute if you're curious. Well, even if you're not curious, I'm going to show you. And then the minus 8, the minus 8. So you guys remember when we were doing this before? The h's have to cancel out. And now you see why. Because what do I get when I put a 0 in for h? Don't I get 0 over 0? Right? I get 0 over 0. So what do I want to have happen? I want the h's to cancel so that it's not zeros anymore, right? And sure enough, the 8's cancel. Can I kill the h's? Or at least some of them, right? No? Isn't this h squared plus 6h plus 12? And what do I get when I let h go to 0 of this? Right,
12.
the h, sorry? 12. Isn't that the same one? Isn't that the slope we got before? We got a slope of 12? Didn't we get a slope of 12? Okay. Now this method right now seems worse, right? Because we had to actually cube this thing. But the trade-off is you don't have to factor anything. You just have to multiply stuff. So that's kind of a nice trade-off. And then I could do all the same stuff. I can say find the equation, the tangent line, but we already know the slope is 12. It would be all the same work. This is just an alternate way to figure out this. What's on the back of you? Nothing. Wow. Let me take a little side note, show you how I got this so quickly. Oh, we got a little bit of time, and then we might do one more example here. Let's see. No, just get in there. Okay. Holy shit. Okay. Oh, this is all dirty. And sorry, we'll be fine. Have you guys ever seen? All right. Have you guys ever seen this? Anybody ever seen this before? Anybody? There it is. Chloe knows. Oh, and Carmen, yes. Either method works. Sometimes one method is easier, and sometimes one method is close to impossible, right? So sometimes one method is better than the other one. The f of a plus h1 is the one that we kind of go to because it kind of works, and it's easier to work with most things, believe it or not. Now, Pascal's triangle. Real quick, I really, this is so cool. What do you get when you do this? What do you get when you square this? You can do it.
X squared plus 2x plus 1.
What are the coefficients?
1, 2, and 1.
1, right? There's a 1 here. 2, 1. Now, if I were to do this, real quick, stay with me. If I were to do this, isn't this just x plus 1 times x plus 1 squared, right? Isn't that just x plus 1 times this thing? Let's see if we can do this quickly. And then if I do that, I get x cubed plus 2x squared plus 1x squared is 3x squared. Plus 2x plus 1x is plus 3x. And then 1 times 1 is 1. Isn't that, what's the coefficients? 1, 3, 3, 1. So if I did x plus 1 to the 4th, that would be this level. That would be x to the 4th plus 4 x cubed plus 6 x squared plus 4 x plus 1. Okay, now, so what did I do? Because I didn't have a 1 in there, did I? So here's what I did. So let me make it even worse. So what if I had 2x plus 3 to the 3rd power? Okay, so the coefficients are going to go a coefficient of 1, but then it starts off with 2x times 2x times 2x. It's all of these. So I got 3 of those. So like if I had, oh man, Jeff, I wanted to do this quick, but there's no real good way to do this quickly. One thing I could do is 2x times 2x times 2x, correct? Maybe, no, maybe, not really, okay. Plus, the next coefficient is 3, and then I have 2 of these and 1 of these. The next coefficient is 3, and then I have 1 of these and 2 of these, and then at the end, the coefficient is 1, and I have none of these and all 3 of those. So it kind of like builds from everything of the first one, and then less and less and less, and then in the last one is everything of the last one. I have no idea if this makes any sense. No idea. I'm just doing this quickly because you could do it without Pascal's triangle, but it makes things quicker. And then I get 8x cubed plus 412x squared. Well, I'm sorry, I left out a 3. Sorry, let's see if we do this again. 4, 12, 36. Plus 927 times 2 is 54x plus 27. That's what you would get if you multiply this out. Bam, bam, bam. Pretty useful, yes? Has anybody never seen any of this before? Like nothing. Has anybody never seen this and how it's used? And everybody's seen it to some degree? Okay, cool. All right, that was all right. I didn't have to do it. All right. Do you want to try to let me think, is there anything I could do generally or another example? Let me think. You want not really. Okay. So let's just try. Oh, let's do this. Let's do this. Let's end on a freaky ass note. What about, real quick, have we talked about this yet? Have we talked about that yet? I think we did. I'm pretty sure I threw this in there. We did a table of values. I'm almost certain we did, but maybe we didn't. This is 0 over 0, correct? But if we do a table of values, I'm pretty sure we did this with the table earlier. Can anybody help me? If you put a 0.1 in, you guys have your calculators right there? Can anybody help me with this? Let's, and be careful, you gotta be in radians, right?
0.0998.
0.99, and then you divide by 0.1, so you get 0.998, right? Oh no, I'm sorry, you're probably right. 0.0998, you did divide. Okay, and then 0.01, you get point, did I do this? Oh, it is 0.99. Okay, let's try this again. When you put a 0.1 in, you get 0.0998 divided by 0.1 is 0.998 stuff. And if you do 0.01, you get 0.99998. So can somebody, what do you think it's going to as you approach 0? What do you think this is going to?
1.
1.
1. So the limit of this is 1. And what's really cool about that is sine of x is approximately x if x is close to 1. I'm sorry, close to 0. That's really neat. What is sine of 0.053? Somebody do sine of 0.053. What is it?
Point 0.052975.
0.529. If you round that, isn't that the same thing? Isn't that 0.053?
Yeah.
So the smaller your input gets, this ratio becomes 1. So sine x becomes x if x is really small, if x is close to 0. That is really useful thing to know. Now, what does that have to do with anything? Well, I want to know what's the derivative. So if f of x is sine x, what is f prime of x? So let's set this up. F prime, well, let's say f prime of a. Why not? What's f prime of a? So let's say f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. So this will be the limit as h goes to 0 of sine of a plus h minus sine of a all over h. All right, is that decent? I haven't done any real work yet. I just threw shit in. Just throw it in there. Now, here's why I love doing this example. Does anyone remember anything that would help us with this piece? Sine of a plus h. Does anyone remember what sine of the sum of two angles is? Oh, this is one you're supposed to have memorized.
Isn't it like a half angle formula or something like that?
Oh, sort of. I mean, it leads to that, but that's not where we are yet. So here it is. Oh, and by the way, I'll put both of these up here. And by the way, I don't know if we're going to finish this. I just want to get it in your brains. But watch this. This is important. This is really important, guys. Cosine is an asshole. Cosine is an asshole. Cosine is a jerk. Cosine sucks. So this is what I remember. This is how I remember a lot of identities. This is the one that started it off, and then I realized that cosine is an asshole in a lot of places. So what do I mean by that? Sine is nice. Sine says, oh, let's take turns. I'll do A and you do B. Oh, let's keep this plus. I'm not gonna mess with it. Let's keep that a plus. And now you get it, I'll take B and you take A. That's what sine does. Cosine says, screw you, man, me first. I do all the shit, it's me first. Screw you. Oh, you got a plus? I don't give a shit. I'm gonna make that a minus. And now you get at the end. You can do your shit there at the end. I'm done. I don't know. I don't know if you guys. I don't know if that makes sense anyway. Now, obviously, I didn't just prove anything. I go through a whole thing in my pre-calculus class where we actually prove these things. Hopefully, these are somewhat familiar. So what would sine of A plus H be then?
Sine A times cosine H plus cosine A times sine H.
I like it. Now. So that's, I can maybe I can do this. Maybe. All right. Let's see. So this will be sine A cosine H plus cosine A sine H minus sine A over H. Real quick. What do I get with cosine when I put a 0 in? What's cosine of 0? It's 1, right? Right? So this is times 1. And what's sine A minus sine A? They cancel, yes? And, is everybody cool so far? Right? Cosine goes to 1. Sine A minus sine A is gone. And what is the limit? What's the limit of sine H over H? Just like sine X over X. What's that limit?
1.
1. So this becomes cosine. So the derivative of sine is cosine. That's nice. That's nice. Okay, all right. Sorry. Some of you guys knew that already, maybe, but it's just kind of neat. So you would hope that the derivative of cosine be sine, and you would be wrong. So we'll talk about that later. But I think that's plenty of stuff for today. So again, Wednesday, we'll have a quiz, 2-1 through 2-3. I'll have a practice test ready. And Friday and Monday are holidays. So the following Wednesday will be review day. So this Wednesday, we're going to finish up chapter 2. We basically did. I just got to fill in. Well, we didn't really, but there's some details to fill in. So let me know. You can hang out if you have any questions. Otherwise, you're free to head out, and I'll see you on Wednesday. Anytime. Thanks for coming. You do the same. Thank you.
Professor, I was going to ask a question
Yeah, go ahead.
because I'm not gonna lie, but it's a lot of homework. So it's like, man, like I don't want to sound like I'm like bitch or anything, but it's like